Okay, so let's see if we can figure out how to solve this math word problem, which is the following. To grow $4,000 into $20,000, how many years would you need to invest at a 7% annual compound interest rate? All right, now feel free to use a calculator. Also, feel free to find or research any formula that you think you need to solve this problem. Just make sure to do all the math on your own. But if you have an answer, go ahead and put that into the comment section. I'll show you the correct solution in just 1 second. Then, of course, I'm going to solve this problem step by step. But before we get started, let me quickly tell you who I am. My name is John, and I have been teaching middle and high school math for decades. And if you want a nice, easy to understand way to learn math, well, then check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to like and subscribe, as that definitely helps me out. All right, now before I show you the answer, let's take another look at the problem. So to grow $4,000 into $20,000, how many years would you need to invest at a 7% annual compound interest rate? All right, so let's take a look at the answer. The correct answer here is approximately 23.78 years. All right, now if you got this right, well, you definitely got a happy face and an A plus. And if you're like, Mr. YouTube Math Man, I don't even know what formula to use. Can you help me out? Well, I definitely can. All right, so let's go and get into it right now. And of course, we are talking about compound interest. And there's different formulas for compound interest, but the formula that we're going to be using is ideal for annual compound interest. So this means that we're compounding our investment annually or every year. Now, you do have other kind of investment situations. You can have continuous compound interest or daily compound interest or quarterly compound interest. And those situations would require different formulas. I'll show you the correct formula in just 1 second. But we do need to understand some basic investing concepts to solve this problem. So let's take a look at the formula and then review some basic investing terms and definitions right now. All right, so this is the formula that we need to use. It's A is equal to P times parentheses 1 plus R to the T power. All right, so let me go ahead and explain this formula. Now, let's suppose we work real hard and we save up some money and we want to invest that money. Now, this starting amount is called the principal amount. And in this particular formula, that is the P, right? So our starting amount is the principal and that is the P. Now, we're going to be investing this money for a period of time, right? So because we are dealing with an annual compound interest investment, this period of time is going to be in years, right? So this T up here is the time that we're going to have this investment in years. All right, so that is what T is equal to. Now, this particular investment, like we're going to put this money in a bank or some other financial institution, and we're going to get a return on this investment expressed as some sort of interest rate. So this R is the interest rate that we're going to get. Now, this is an annual compound interest rate expressed as a decimal. All right, so that's what R is. All right, so now that we have this money and we're going to invest it for T years at this R interest rate, the total amount that we're going to get when we are done investing is A, right? So this is the total amount of money we will have after investing for T number of years. Okay, so what we need to do here is apply this formula to the problem. All right, so here is the problem, and let's go ahead and see if we can identify what the principal amount is here. So to grow $4,000 into $20,000, which one of these amounts do you think is the principal amount? All right, now you're probably saying, hey, Mr. YouTube Math Man, it's got to be $4,000 because that is our starting amount. All right, well, that is absolutely correct. So that means $20,000 is what? Well, this is the total amount that we have after a period of time. So this $20,000 is going to be our A. And then, of course, our interest rate, our annual compound interest rate is 7%. So the question is what? How many years, right? So we're looking for this variable T. So let's go ahead and plug in all this information into the formula. All right, so it's going to look like this. So our A is $20,000, right? That's our total amount after investing this principal for a period of time. So our principal amount is $4,000. Now R is our annual compound interest rate expressed as a decimal. So that's 7%, and 7% as a decimal is 0.07. So remember, to change a percent to a decimal, we need to divide by 100 or move the decimal point over 2 places to the left. All right, so that means that we're looking for t, which is, of course, time in years. So this is what we need to solve for in this formula. All right, so when we plug in all the numbers, we're going to have this. So we have 20,000 is equal to 4,000 times 1 plus 0.07 to the t power. All right, so we need to solve for the variable t. So before we get into this, let's go ahead and just add up what's inside of the parentheses here. So we have 1 plus 0.07, that is 1.07. All right, so what kind of equation are we looking at here? Well, if you're saying, hey, Mr. YouTube Math Man, this variable is in the exponent location of this power. Is this an exponential equation? Well, indeed it is. Okay, so we're going to have to use some fancy math here, and some of you may not have learned this, but stick with me. It's not that difficult. All right, so let's go ahead and take the next step, which of course is having you quickly subscribe to my YouTube channel. Now, my channel is all about trying to make math clear, understandable, and interesting. But really, I'm trying to reach as many people as possible. And the only way I can do that is to get your support. And the best way you can support this channel is to simply hit that subscribe button and then hit that bell notification so you can get my latest videos. Now, if you are not familiar with logarithms and exponential functions and equations, check out my full main math courses in the description of this video. You'll find links to two courses. One is my Algebra 2 course, and the other is my Pre-Calculus course. Now, I'm going to be going over some math here that some of you may not be familiar with, but these two courses, I will teach these concepts in detail. All right, so we're going to be talking about logarithms. So if you have your scientific calculator available, and if you ever wonder what that LOG button does for us, or this LN button, well, I'm going to show you right now. All right, so let's go ahead and get into this. So here is our equation, right? So we have 20,000 is equal to 4,000 times 1.07 to the t power. Now, what we want to do here is get this equation to something like this. So if I had like 2x is equal to 10, what I have here is a power and exponent, or a power. Okay, in other words, we have a base and an exponent on one side of the equation and a number on the other side. So the first step we need to take here is we need to kind of get this part of the equation all by itself on one side, and then we want to get a number all by itself on the other side. All right, so how can we get rid of this 4,000 in front of this 1.07 to the t power? Well, if you're like, hey, Mr. YouTube Math Man, we can just divide both sides of the equation by 4,000. Well, you would be right. All right, so let's go ahead and do that. And when we do that, we're going to end up with this. All right, so 20,000 divided by 4,000 is 5, and then 4,000 divided by 4,000 is 1, but that leaves us with 1.07 to the t power. Okay, now at this point, we are going to use logarithms, and this is a big, important topic in advanced mathematics. So again, if you haven't taken this math, you can find this in my Algebra 2 and or Pre-Calculus course. Also, I have a ton of additional videos on my YouTube channel. But what we need to do here is take the log of both sides. We're going to take the logarithm of both sides, and that's going to look like this. All right, so we're going to have log 5 is equal to log of 1.07 to the t power. Okay, so if you do have your calculator and you're just wondering what this means, well, go ahead and put in log 5. You'll see that you're going to get some sort of number, some sort of decimal in your calculator. So a logarithm of a number is just a number. All right, but we need a real important property of logarithms to solve this problem, and that is the following. So here we have log of 1.07 to the t power. So this variable t is up in the exponent location, but we have a property that allows us to put it right in front of this log. All right, so we're going to take this t and put it right in front of this log, and the reason we can do that is a property of logarithms. All right, now here we have log 5, which again is a number, okay? And now we have log of 1.07. This is a number. So this is really a basic linear equation. So let's just replace these logs here with some other numbers, maybe like 10 is equal to t times, let's call this 2, right? So this is a number equal to t, okay, times some other number. So how would you solve this equation algebraically? If you had 10 is equal to t2, this is the same thing as 10 is equal to 2 times t, right? So to solve for t, all we need to do, excuse me, is divide both sides of the equation by what's in front of the t, which in this case is 2. So that's what we need to do here. To solve for t, what we need to do is divide both sides of the equation by log 1.07. So you don't want to use your calculator just yet, so let's go and do that right now. So when we divide both sides of the equation by log 1.07, we're going to end up with log 5 divided by log 1.07. Okay, so that is what t is equal to, and now we'll plug all this into our calculator, and we'll get something approximately equal to 23.78, which of course is what t is equal to, right? So what was t? T is time in years, right? So we have to go back to our formula and recall that t, again, is time in years. All right, so hopefully this was a nice review of simple compound interest. Now, again, there's all different sorts of compound interest problems that you can solve, like continuous compound interest or daily compound interest. But I think a good starting point is to get really good with these annual compound interest problems and then kind of go from there. All right, so with all that being said, I definitely wish you all the best in your math adventures. Thank you for your time and have a great day.